Happy Wednesday, everybody. Today is the first Wednesday where we're doing Spirit Days, and today is kind of showing off your study buddy. So if you have any critters, basically. So if you have a puppy or a cat, a rabbit, somebody that just kind of hangs out with you while you're studying, if you pop in during my office hours, I can give you guys 5-star points. So if you haven't gotten the memo on that, just wanted to give you a heads up, okay? All right, let's look into more about solving x-intercepts. So using the function that they provide us, convert into vertex form. All right, this looks a lot like what we did yesterday, right? So converting it into vertex form, half of -6, well, I guess I'll write it all the way out because I don't want to confuse you guys. So half of -6 is -3. -3 squared is 9. So since I added 9 to the equation, I have to subtract 9 from the equation. So then that gives me a -5 at the end. Okay, so then it says, use the vertex form of the equation to find the exact values of the x-intercepts. Well, remember, x-intercepts are a number, comma, 0. So I'm plugging in 0 for y, or in this case, f of x. And because it's in vertex form, I'm just going to literally solve for x. So add 5 to both sides. Take the square root of both sides, but here's the problem. Square root of 5, not really a nice number. So here's how we notate that. The right is still x minus 3, just like it was on our video yesterday. But what we're going to do is, because we don't know the square root of 5, don't make it a decimal. Just turn it into plus or minus, so it's still plus or minus, square root of 5. Then when I go to add 3 over to both sides, it looks like 3 plus or minus root 5. So if that's kind of weird, like that's a new notation we really haven't done much with at all. Basically what that means is one x-intercept is 3 plus root 5, comma 0, and the other one is 3 minus root 5, comma 0, right? And so really, if you actually wanted to plot this on a graph, you would use the decimal instead of square root of 5, right? But what happens is most of the time in math moving forward, like when you get to algebra 2, but also on things like SAT and ACT, they tend to leave their answers as radicals because they're more accurate than using a decimal and kind of rounding. Okay, so today's going to be kind of a focus on what does that look like when we've got weird answers like that. So letter C says, convert the original standard form equation into factored form and find the x-intercepts. And I say, okay, well, factored form, I am going to use x and x. And I need two numbers that add to give me -6 and multiply to give me 4. Well, that's kind of a problem because to multiply to give me 4, I can either use 1 and 4 or 2 and 2. Neither of those added together in any way, shape, or form with negatives or anything like that is going to add to give me -6. So the problem with this one is it's not factorable. So let's make a connection right here. Because this is not factorable, doesn't it kind of make more sense that the x-intercepts are weird numbers, right? Like if it factored into, I don't know, x plus 3 and x minus 2, you'd have really nice 3 and 2 as x-intercepts, right? So the fact that we got kind of weird answers over here actually directly connects to the fact that it's not factorable, right? That there's not going to be a nice answer. So there are going to be times where if I give you something in standard form and I say find the x-intercepts, you might have to choose one way or the other based on, well, is it factorable? Can I complete the square? Like, what's my best route? So here's a little note down here at the bottom. What if we answer plus or minus root 24? So instead of like we got plus or minus root 5 in our answer, okay? So what if it's plus or minus square root of 24? Can we simplify these? And if so, how? So here are some examples that you might see when you are solving these types of questions. Basically, here's what you're going to ask yourself, okay? We're going to skip these two guys for now, okay? But what you're going to ask yourself is, what are all the perfect squares? Meaning, what's 1 times 1? Well, that's 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, so on and so forth. So I'm going to write out all the perfect squares. 11 times 11 is 121, but usually you don't use that one. So those are all my perfect squares. Here's what your goal is. You're trying to look at these square roots and figure out what's the largest perfect square that the number underneath the square root divides by nicely. So here's what I mean by that. Square root of 18. Well, 18 does divide by 1, but that's usually 1 we don't use, you guys, because it's not very helpful. It doesn't actually simplify anything, okay? Does 18 divide by 4? Nicely. Well, no, I would get a decimal, so that's not going to work. 18 divided by 9. Well, that works, and it's 9 times 2, right? And I know I can't do 18 divided by 16, so 9 must be the largest perfect square that works. So 18 is the same exact thing as 9 times 2. Notice how I haven't done anything, technically, right? 9 times 2 is 18, so I haven't done anything weird. So this is a new property for square roots. If you have something like this, you can split it up so each number has its own square root. Now that can only happen when you are multiplying in the middle, like we are doing right now, okay? And then we say, well, what is the square root of 9? The square root of 9 is 3. Now in this case, you don't need to worry about plus or minus. You'll see the plus or minus will come in when we're doing the actual solving. Right now, you just write 3. And the way we write 3 times root 2 is we just write them right next to each other, just like that. So here's what I want you to do. Why don't you practice these next 3, pause the video, and then when you're ready to see the answers, unpause it, and let's see how you do. All right, so square root of 72. All right, and off to the side, what you guys aren't seeing is I'm literally going to type in all these numbers. So 72 divided by 4. Well, it's a nice number, but it's 18. That's what's left over, and that seems kind of big. So I bet you there's a bigger perfect square that works. 72 divided by 9, I get 8, which is good, but again, I still think there's one that's bigger. 72 divided by 16, nope, I get 4.5, that's not going to work. 72 divided by 25, that's obviously not going to work. 72 divided by 36, there we go. That's the biggest one I want, 36 times 2. Okay, I'm going to show you what if you stopped at 9. I'm going to show you how that works, okay, in just a second. But really your goal is, and the easiest route is to find the largest of all these numbers that it divides by nicely, okay? So this turns into square root of 36 times square root of 2. The square root of 36 is just 6, so my answer is 6 root 2. All right, let's say you didn't notice that. Let's say you did 9 times 8, okay? Square root of 9 is 3. So you would get 3 root 8. Well, that's obviously not the same thing as 6 root 2, right? But notice the square root of 8 actually divides by 4 again, which is another perfect square. Then we get 3 times root 4 times root 2. And then root 4 is just 2, so 3 times 2 is 6 root 2, which is literally the same thing we got here. But notice both those routes, you guys. This route versus this one. I think we can all agree using the 36 is way easier. So that's why you're trying to look for the biggest one, okay? Let's look at square root of 45. I think I want to use 9, so 9 times 5. Notice how I'm always putting the perfect square in the front, and here's why. I'm going to start skipping these steps and saying, okay, well, square root of 9 is 3, and the 5 is still stuck under the square root. All right, let's do 12. 12's biggest number would be 4. I can divide it by 4 and 3. So square root of 4 is 2, and then the square root of 3, the 3 stays stuck underneath it. So let's see if we can connect this to what we were talking about the other day. All right, solve for the x-intercepts for all 4 of these equations. Go ahead and pause the video at this point in time, give it a try, and then when you're ready, unpause it and check your answers. All right, so x-intercept again means number, comma, 0. So I'm plugging in 0 for y. Okay, so my x-intercepts here, this guy's going to give me an x-intercept of positive 1, comma, 0. This guy's going to be negative 5, comma, 0. Let's look at the x-intercepts over here. Plug in 0. Now, remember what happens with that negative 3 in the front. It's kind of like I'm dividing both sides by negative 3, and 0 divided by negative 3 is just 0. So the negative 3 drops off. Here's where you have to be careful. You're going to want to say your x-intercepts are positive 4 and positive 1. That's not the case. Now, one of your x-intercepts is positive 4. I'm cool with that. But because this guy has a 2 in the front, it's totally different. It's like you're setting 0 equals 2x minus 1. Add 1 to both sides, and you get 1/2. So your other x-intercept is 1/2, comma, 0. So don't forget, when there's a number in that parenthesis, like that 2's right there, you got to be a little careful. All right, let's look at number 2, solve in vertex form. So again, it's x-intercepts, so plug in 0 for y and solve. So in vertex form, there's no trick. You just literally solve. So add 4 to both sides. Take the square root of both sides. Now don't forget, while the square root of 4 is technically only 2, we now know it's plus or minus 2. Then when I go to add the 1, make sure you add the 1 to the front of the plus or minus. So you can say, okay, one of my answers is 1 plus 2, which is 3, 0. My other answer is 1 minus 2, which is negative 1, 0. All right, that worked out pretty good, so yay. Let's look at letter B. Plug in 0, because we're finding x-intercepts, so plug in 0 for y. All right, subtract 36 on both sides. Be careful right here. The next step, you're going to want to take the square root of both sides. Resist the urge. You need to get rid of the minus 2 first. So that turns into 18 equals x plus 3 squared. Square root both sides. So we get plus or minus root 18. Okay, well, that's not a nice, neat square root, so we're going to hold off there. And then I'm going to subtract 3 from both sides. But remember when we subtract 3 from both sides to put it in front of the plus or minus. This right here, if we were doing traditional quizzes, tests, things like that, this would be a yellow because we just learned on the last page that square root of 18 can be split up into 9 times 2. And 9 is, square root of 9 is 3. And square root of 2 we don't know, so we keep it under the square root. Those are my 2 x-intercepts. So you can either leave it just like that, or you can literally write 1 x-intercept is the positive version, 1 x-intercept is the negative version. So you can see it either way. Either leave it like this, or you can literally write them out, okay? So we don't know how to solve for the x-intercepts using standard form. So what should we do first to be able to solve? Well, if we can't solve in standard form, you have 2 options. Convert it to vertex form and solve it, or factored form and then solve it, okay? So we can't solve straight from standard form, but we can convert into those other 2 forms and then do exactly what we did on this last slide. So the big thing you have to think about is which way is the better route. So if I give you an option, which is the easiest way to go? But most of the time I'm going to say convert this into vertex form and then solve, or I'll give you some direction. All right, last thing, okay? Finding x-intercepts, you plug in the 0 yourself. Solving a quadratic, they've already plugged in the 0 for you. So for example, let's look at this equation right here. There is no y. So it's like, okay, if I'm finding x-intercepts, there isn't a y for me to plug in 0. Well, what I want to do is set all this equal to 0. So I'm going to add that 24 to the left side. Notice how the 0 magically already appears. That's because we are going to solve this equation. Okay, so there's a difference. Like the process is exactly the same, but if I say solve a quadratic, you don't have to worry about plugging in 0. You just use the same techniques. So here I would either complete the square and change it into vertex form and solve it, or I'd try to factor it. Okay, so there's a lot of different options there. So the difference is if I ask you to find x-intercepts, you have an equation like these guys where you have to plug in the 0 yourself. If I'm saying solve the equation or solve the quadratic, it'll look more like this, where the 0 just kind of magically appears once you move everything to the left side of the equation. So that's your first step, is you always want to move everything to one side of the equation. If you have a choice, try to keep x squared as a positive number if you have a choice. So sometimes you have to move it to the right side of the equation to make that happen, okay? But you'll see what I mean when you go to start your homework today. Don't forget, you guys, this is a huge concept that comes back in Algebra 2. And while I know that it's kind of a struggle to learn on your own and things like that, I really want to encourage you guys to do the absolute best you can so that when you do get to Algebra 2, you're ready for these concepts because they can be tricky and they do come back, okay? So don't forget, if you're getting stuck, if you have questions, stop by and see me during office hours or send me an email so that I can help, okay? All right, we'll chat soon.